Hello everyone, and welcome back to another episode of the Internet Computer Developer Journey. In today's episode 3.6, Motoko Level 3, we're going to be going over some of the advanced features of Motoko, including principals and color identification, shared functions and futures, and we are also going to be talking about pattern matching and periodic tasks. So let's jump right into it. So the first topic that we're going to cover, principals and color identification, branches off of what we covered in the previous module, 3.5, Identities and Authentication, where we talked about the different forms of identity on the ICP, and we took a look at how to integrate internet identity into an application. In this Motoko level, we're going to look into color identification, adding access control with identities, and then we're going to end with pattern matching and periodic tasks. So to get started, in Motoko, when you have a shared function, it supports the form of color identification, which allows principals that are associated with a color of that function to be returned to the function. Remember that a principal is a unique identifier that is associated with either a user or a canister, and principals can be associated with other entities on ICP in the future, but currently they are used for users and canisters. So recall that in Motoko, we can use the shared keyword to declare a shared function, and that a shared function is going to return a value known as a future. Future values indicate that an asynchronous value is expected to be returned, and a shared function's arguments and return values must also be shared types. We covered shared functions more in depth in level 2.6, Motoko level 2. So if you need a refresher, go ahead and take a look at that tutorial. But so to look at a basic demonstration of how a caller's identifier can be returned to a shared function, we can define a shared function that takes the input of a message and then returns an async value. So in this basic example, we have a shared function called inc parentheses that specifies a message as a parameter, a record, and then the msg.caller assesses the principal field of msg. Any calls to the inc function do not change, and when the call is made, the caller's principal is provided to the system, not the user, so the principal cannot be forged or spoofed maliciously. This syntax can also be used for actor classes instead of just an actor, such as shared MSG actor class, counter, init with data type nat. So to further this example, you could have a scenario where the counter actor that we've used in previous tutorials is something that you want to restrict access to. And so you can modify the original example that was just using a function so that only the principal that installed the actor can modify the actor by recording the principal and then binding it to an owner variable, then checking that the caller of each method is equal to the original variable. So if we want to take a look at that code here, we define this shared actor class called counter. We let owner equal message.caller, so we're taking the principal of the caller and storing it as owner. And then we are defining a variable called count, which is going to store the initial value of data type nat. And then we're going to declare a public function that is going to assert that if the owner value equals the message caller value, the counter can be increased by a value of 1. And then we can define a read function that can just return the current value stored in count. And then this last function here includes this term bump, which is used to trap if the call is unauthorized, preventing any modification of the count variable, while the read function permits any caller. So these first and last functions are restricted to only being called by the owner, whereas this read function can be called by anyone. So that's a simple example of how access control can be implemented in a DApp using identities. But now let's look at a more complicated sample application that uses role-based permissions to control different operations. So in this example, we're going to create a simple application that displays a different greeting for users based on their different role. We're going to have an owner, an admin, and an authorized. For any users that have the admin role, they're going to receive the greeting, "You have a role with administrative permissions." For users that have the authorized role, they're going to receive the greeting, "Are you enjoying your developer journey?" And users that aren't assigned a role are going to just get the greeting, "Nice to meet you." Only the principal that initialized the canister is going to be assigned the owner role, and only principals with the roles owner or admin can assign roles to other principals. So before we get started, make sure that you have your developer environment set up according to the developer environment setup module 0.3. And then we're going to navigate into our working directory, which for me is going to be this developer journey subdirectory. And then I'm just going to make sure that DFX is running by using DFX start clean background. And for me, DFX is already running. Then I'm going to create a new project with the command DFX new. I'm going to call this new project access_hello. And since I am using a version of DFX that is higher than 0.16, I am going to have this interactive prompt for selecting which backend language, which front-end language, and any other frameworks that I want to include in the project that are supported by default. So I'm going to select Motoko. For the front end, I am going to select no front-end canister since we aren't going to be doing anything with the front-end UI in this tutorial. And then I'm not going to add any additional features. And so then I'm just going to navigate into that new directory with cd access hello. And then we need to create a new identity called owner that we want to be the owner of our canister. So let's use DFX identity new owner. And for me, this identity already exists, but so then I'm going to use DFX identity use owner to switch my instance of DFX to use that identity. So now we're going to be writing some code. For this, I'm going to open up my IDE of choice, which is going to be VS Code. And I'm going to navigate into my developer journey subdirectory, and then this new access hello directory that I created. And then I'm just going to make this a little bit bigger and then fit it over here so we can take a look. And in this, I want to open this main.mo file. And I'm just going to close the Explorer. And for this, I'm going to remove all of the previously existing code. And then first we want to import a couple base modules. We want to import the association list base module, the error base module, and the list base module. So I'm just going to copy this snippet over here and paste it. And then next we're going to declare a shared actor class, which makes 3 role-based greetings to display using an if-else statement. So I'm going to copy this and then we can talk about it. So first we're going to define our shared actor class. So shared caller equal initializer actor class. And this is going to have a public shared function called greet that is going to take a parameter of type text that we're going to call name, and it's going to return an async value of type text. And we're going to use an if-else statement in this actor class to determine which greeting we're going to reply to our caller. So if the caller has permission assign role, so that means that they have administrative permissions that they can assign a role to somebody else, it's going to return hello and then name, which is the text that we pass to the function, and then the greeting, you have a role with administrative privileges. Else, if the caller has permission lowest, means that they are just an authorized user. That's the lowest permission that we are going to set. We're going to return hello name, you have an authorized account. And then else, if the caller doesn't have either of these permissions, so they don't have the lowest and they don't have the administrative assign role permission, we're just going to return greetings, nice to meet you. So now that we have that, we need to define some custom types for our role and permission. So we want to define a public type role. We want to have 3, owner, admin, and authorized. And then we're going to define our permissions of assign role and lowest. And so assign role is used up here to determine if the user is an admin, and lowest is used here to determine if the user is authorized. Next, we want to define some stable variables to store a list of principals and their associated role. Remember that stable variables are stored in stable memory, meaning that they will persist if we upgrade our canister in the future. So we have a private stable variable called roles, and here we're going to use the association list where we are associating a principal with the role. And then we are going to also make one called role requests, where we use the same format where we want to store principal with its role. Now we're going to create a function that checks if principal A equals principal B. And we want to bring this over a little bit. Then we're going to make a function that returns the principal's current role, that first checks if the principal is the owner or initializer of the canister, and then it checks the list that stores the principals and their associated roles to see if it has one stored in that list currently. So function called getRole, and it's going to take input of type principal and it's going to store it as pal. If pal equals initializer, it means that it's going to be the owner. If it's not the owner of the canister making the call, we're going to look into that list that we created to store the associations of principals and roles. So now that we have a function to determine if the caller is the owner of the canister, we need to write a function to determine if the principal making the call has permissions. So now we're going to use this function called function has permissions, and it's going to take the input of the principal and the permission, and it's going to let role equal get role. And we're going to use a switch statement to determine the role that the caller has. Then we also want to define a function that's going to reject any unauthorized principals. So we want to require permissions be assigned to a principal. So we are going to define this function require permission that's going to throw an error that returns unauthorized. And then we're going to define a very large function that actually assigns the role to a caller. So this is going to be a public shared function called assign role. It's going to take the parameters of principal stored as assignee and new role stored as role, and it's going to return an async response. So it's going to await this function to finish before it starts its switch statement with the first case as owner, which is going to throw an error, which means that it cannot assign anyone to be the owner since that is an unassignable role. Then it's going to also use an error statement that if the assignee equals the initializer, which is the owner, it's going to throw another error that says you cannot assign any role to the canister owner. Then it's going to take the list roles that we created and it's going to replace the principal and role values with the role, assignee, principal, and the new role. And then it's going to do the same for role requests. And then we're going to define a public shared function called request role that is going to return an asynchronous principal. And it's going to take that role requests list and it's going to replace the principal and role in that request with the role requests, caller, principal, EQ, and role. So it looks similar to the role requests definition that's in the previous function, but you can see that instead of amending the role requests list with assignee and null, it's going to use caller and role. Then we're going to define a function that returns the principal of the message caller or the user identity. So that's going to be this public shared function called caller principal, and it's just going to return the principal of the caller. So it's going to return caller. And then lastly, we are going to return the role of the message caller. So we are going to use a couple of functions here. Where we are going to define a public shared function called myRole that's going to return getRole for caller. Then we're going to also have one that returns the role request for the caller. Then we're going to define a public shared function that returns the entire list of role requests. And then we're going to define a public shared function that returns all roles. But for this function, this is going to require permission of caller assign role. So it's going to require the admin role. And that's going to be the same with this get role requests function. Both of these require that you have the admin privilege in order to call and get a response for those. And if we scroll back up and we take a look at our assign role, we can also see that our assign role function also requires our admin privilege to call that. So in total, our code should be all put together and ready to use now. Some key components of this app include the greet function, which uses a message caller to determine the permissions that should be applied to a principal. Then it displays a greeting depending on the permissions associated with the caller. It defines two custom types, roles and permissions. It uses an assign roles function that enables the message caller to assign a role to a principal if it has the correct permission. It uses a caller principal function to return the principal associated with an identity. And it also defines the myRole function that returns the role associated with the caller identity. So now that we have this code ready to go, we can save it. I'm going to hit Control S, and then I'm going to open my terminal and run DFX deploy. And so now our canister has been deployed. So now we can take a look at how to interact with it and test out those functions that we just wrote. So first, let's confirm the identity that we're currently using. So DFX identity, who am I? And we are owner, since we switched into using the owner identity before we got started. Now let's take a look at the principal for this identity. So let's use DFX identity get principal. And so this is the principal value for my identity. Now let's see if this identity's role is associated with the canister, which it should be since we used this identity to deploy the canister. So it should be the owner of the canister. So we're going to use DFX canister call, access, hello, backend, and then we want to call my role just to return our role and I misspelt my canister name. And we can see that it returns owner since this principal is the one that deployed the canister, so it's the owner. So now let's create some new identities and assign them different roles. So let's create an identity called DFX identity new. We'll call it IC_admin. For me, that identity already exists, but then let's confirm that this identity doesn't currently have a role with this canister. So let's use DFX-identity IC_admin, canister call, access, hello, backend, and then call my role. And so this returns value of null since there is no role assigned with this identity. So let's now use DFX identity use IC_admin. And then we're going to use 2 amperstamps because we want to run another command, DFX identity get principal. So now we can see we are using identity IC_admin and it returns the principal. So now let's go back to using our owner identity, DFX identity use owner. And then we want to assign the role of admin for our principal value for IC_admin. So we want to use DFX canister call access _ hello _ backend. And we want to call the assign role function. And then we're going to use a single quote, 2 parentheses, principal, and then double quotes, and we're going to put in our principal. So I'm just going to copy and paste it and close that with a quote and a parenthesis, comma, opt variant, and then we're going to use curly brackets, admin, and close that with a parenthesis and a single quote. And if successful, we're just going to get this empty bracket for returns. And so now if we use that command we used before, DFX flag identity IC_admin, if we call that, instead of returning null, it should return admin. So now let's call the greet function for this IC_admin identity. So DFX identity IC_admin canister call access hello backend, and we want to call the greet function, and then we'll just pass internet computer admin. It's going to return hello internet computer admin. You have a role with administrative privileges. So that is going to wrap up that section on access control and how to use principals within an app. So now we're going to move on to pattern matching, which is a feature for testing and decomposing structured data into individual components. Motoko's pattern matching uses data fragments that are derived from structured data and allows them to be bound to names that you can define. Patterns resemble the structure of structured data in their syntax, but they generally appear in input direction positions, such as after the case keyword in switch expressions or in let or var declarations. So for example, if we take the following call, let name of type text equal full name, first name equal Jane, middle equals M, and last equals Doe. This function call is going to construct a record that has 3 fields, and then it's going to pass it to the function called full name. The call's result is bounded to the identifier of name. The last step that binds the result to the identifier is an example of pattern matching, where name of type text is one of the simplest forms of patterns. We can also take a look at the second example where the input in this is an anonymous object, which is then deconstructed into the object's 3 text fields that are bound to the identifiers of first, mid, and last. And then these values can be freely used in the block that forms the body of the function. Pattern matching can also be used to declare literal patterns, which resemble literal constants. Literal patterns can be very useful in switch expressions, since in case the first pattern match fails, the next pattern match can be checked and so forth. So for example, if we have the switch statement Adrian with type female, we can have a case where the name with type female returns name is a girl. If that fails, it will go on to the next one where name male returns name is a boy. And then if we don't have this custom type defined or passed in this statement, it just has name. It would just return name is a human. This last case in this switch statement is called a wildcard, which cannot fail because it doesn't bind to an identifier. And lastly, we're going to talk about periodic tasks. So canister smart contracts can be configured to execute automatically on a periodic schedule or on a specific delay. To configure this, you can either use timers or heartbeats. A timer is a single expiration or single periodic canister call with a specified minimum timeout or interval, where our heartbeats are a legacy implementation that uses intervals of about 1 second, which is the blockchain's finalization rate. Since heartbeats are a legacy feature, it is recommended that new canisters opt in to use timers instead of heartbeats. And so for that reason, we're going to take a look at an example of a timer. So to support timers, Motoko has the timer.mo library, and the basic example of this is going to create a periodic reminder for logging a message every new year. So it's going to create an actor called reminder. It's going to define a variable called solar year seconds, and then it's going to define a private function called remind that returns an asynchronous value of Happy New Year. And then it's going to use set timer to configure and set a reoccurring timer that is going to go off once every year. So in this example, it's going to use a global timer that issues callbacks from a queue maintained by the Motoko runtime. When lower level access to the canister's global timer is needed, an actor can choose to receive timer expiration messages by declaring the system function called timer. This function takes a single argument and returns a future of unit type async. So that's this private function here. And then lastly, we can take a look at an example of a global timer expiration callback that gets immediately called after the canister starts, such as immediately after installation or periodically every 20 seconds thereafter. So this is a function called timer that is going to go off time.now plus 20 billion, and then it's going to print timer both immediately once the canister starts and then 20 billion nanoseconds after that. So that'll wrap up today's episode of the Internet Computer Developer Journey. If you enjoyed today's episode, be sure to like and subscribe to the DFINITY YouTube channel to stay up to date with all the new episodes. This wraps up level 3. So in the next episode, we'll be jumping into level 4, where we're going to be talking about tokens, tokenomics, and the Bitcoin integration. So be sure to stay tuned. If you have any questions or need any help, be sure to check out the Internet Computer Developer docs, the forum, and our Discord server to chat with other developers also on their developer journey. The description of this video has the links to the documentation tutorial for this video, as well as other resources that may help if you need it. That'll wrap up this week. Take care.